Okay, so now we're going to start hypothesis testing using one sample. Remember, hypothesis testing is used to test a claim about a population parameter. We have a few new terms. First, a hypothesis. A hypothesis is a claim or a statement about a population. And a hypothesis test is a procedure for testing the claim about a population parameter. There are two types of hypotheses. The null hypothesis, which is a statement about a population parameter that includes equality. Okay, symbols that include equality are equals, less than or equal to, or greater than or equal to. And it's denoted by an H naught or an H sub 0, H sub 0. The alternate hypothesis is a statement that does not include equality, such as not equal to, less than, or greater than, and it's denoted by an H sub A or an H sub 1. The null and alternative hypotheses are complements of each other, which means a value from the population parameter either will be in one or the other, but cannot be in both. So some more terms. We also have what's known as the test statistic, and this is a value that's computed from the sample data, and we use it to make a decision on whether or not we want to reject the null hypothesis. Critical or rejection regions are the set of values of the test statistic from the values of the test statistic that cause us to reject the null hypothesis. The significance level, denoted alpha, is the probability that the test statistic will fall in the rejection region when it shouldn't have, same as the alpha that's introduced in the confidence levels. And critical values are the same as we saw during the confidence interval sections, and they're values that separate the critical regions from the rest. Now we have tails. There are three different kinds of hypothesis tests, and they're determined by the tails. A two-tailed test is used when the alternative hypothesis has the not equal to symbol in it. And it means our critical regions are in both extremes, in both tails. The left tail test is when the alternative hypothesis has the less than symbol, and it means that the critical region is in the left region or the left tail. And a right tail test is used when the alternative hypothesis has a greater than, and the critical region is then is in the right tail or the extreme right region. Note, tails are usually considered when we're calculating hypothesis tests by hand. Usually when we use Minitab or other statistical software, we're going to be looking at making our decisions another way. The p-value is the probability of getting a value as extreme or more than the one that we get with the sample data. In other words, it's the probability that the null hypothesis is true. In other words, if the probability that the null hypothesis is true is very small, then we're going to deduce that it probably is not true. And our decisions come. If we're going to use the traditional or critical value approach, we find the test statistic, we calculate the test statistic. If the test statistic falls in the rejection region, we reject the null hypothesis. If the test statistic does not fall in the rejection region, we fail to reject the null hypothesis. The p-value approach is if the p-value is less than or equal to the specified alpha, which is also known as the significance level, we reject the null hypothesis. Otherwise, we fail to reject the null hypothesis. And the confidence interval approach says we reject a claim if the population parameter has a value that's not included in the confidence interval. So, note, here's a couple notes. We either reject or fail to reject the null hypothesis. We never accept it or prove it's true. If we reject the null hypothesis when we shouldn't have because it was true, we have done a type 1 error. Alpha is the probability of a type 1 error. If we fail to reject the null hypothesis when it's false, when we should have rejected it, we have committed a type 2 error. Beta is the probability of a type 2 error. So now let's look at some examples. Let's test a claim about the population proportion P. The requirements: the sample needs to be a simple, random sample. The conditions of the binomial distribution must be satisfied. And again, the test that we're doing requires that n times P and n times Q are both 5 or more. So using Minitab, we go to Stat, Basic Stat, one sample P, the same place we went when we did confidence intervals. We enter in the appropriate data just like we did when we did the confidence intervals, except this time we're going to check the box that says test. Then it's going to ask us for our hypothesized mean or our claimed value. And then you go to options, select the appropriate alternative hypothesis, and with this particular test you need to check the box to use the normal distribution because that's the formula that your textbook is using. So let's look at an example. Okay, we're going to write these numbers down, and then I want you to go to Minitab and see if you get these same values. So X was 39, and then N was the combination of the yeses and the no. So 39 plus 32 was 71. They said the significance level was 10%, and they wanted us to see if the majority. Majority means more than 50% or more than half. So the alternative hypothesis is P is greater than 0.5, and you can either do less than or equal to 0.5 or just plain equal to 0.5. This one, it's both are correct. When you put all these numbers in to Minitab, you're going to get the test statistic and a p-value. The test statistic is going to be the number under Z, and the p-value says P under P. Now, stop this slide for just a minute. Go to Minitab and try entering this information in. And this is our claimed value, so this is what goes on where you hit the button that says, check the box that says test. Then you enter in the claimed value or the hypothesized mean. And see if you then click OK. Then see if you get a test statistic of 0.83 and a p-value of 0.203. If you do, then you did everything right. And our decision, because P is greater than alpha, 0.203 is greater than 10, our decision is do not reject the null hypothesis. In other words, there's not enough evidence to suggest the claim that the majority of people believe this. All right, so now the next type of claim we might want to test is a claim about the population mean with sigma known. Remember, if sigma is known, then we're doing the Z test. So the requirements are a simple random sample, sigma is known, or the sample size is greater than 30, and then the sample standard deviation is a good substitute. The flow chart that was on page 290 that you used in chapter 6 will help you decide whether we're doing testing claims about the mean using a Z test or a T test. The population is normally distributed, or N is greater than 30. Now, it is rarely the case that we use a Z test, right? I told you that in chapter 6. But if N is greater than or equal to 30, then a T test approximates a Z test. They're close enough to be considered the same. Now, using Minitab, you go to Stat, Basic Stat, one sample Z, you enter the appropriate data, go to options and select the appropriate alternative hypothesis. So let's try this example. It's chapter 7, section 4, number 5. N was 50, the mean was 120, standard deviation was given to be 12, and our significance level is 5%. Since it says we're testing the claim that it's greater than 118, then that is our alternative hypothesis, and the null hypothesis is mu is equal to 118. I want you to write these numbers down, stop the PowerPoint for a minute, go to Minitab, put this stuff in, put this information in, see if you get this as your test statistic and this is your p-value. All right, so stop for just a second, try. Hopefully you got these. If you did, then you did everything right. Now again, this is larger than my significance level, so P is greater than alpha again, so we do not reject the null hypothesis. Now, what about testing claims about the population mean when sigma is not known? All right, remember you're using the flowchart to decide that this would be a t-test. Our sample needs to be a simple random sample. Sigma is not known. The population is normally distributed, or n is greater than 30. And if n is less than 30 and the population standard deviation is unknown, then the t-distribution is appropriate. The flowchart on page 290 helps you decide if you're going to the t-distribution or a z-distribution. Using Minitab, we go to Stat, Basic Stat, one sample t. We enter the appropriate data and go to Options and select the appropriate alternative hypothesis. So here's the examples, Chapter 7, Section 5, Number 9, and n was 20, x bar was 120, sorry, it must be a 0, 120. Standard deviation is 12 and alpha is 0.05. We're doing essentially the same test we did with the z-test, but notice our test statistic, when you could do this, you could try this with Minitab. See if you get this test statistic and this p-value. You don't need to worry about confidence intervals. I get that question often. We're not doing a confidence interval test, so you can ignore the confidence level. Again, this p-value is greater than the significance level, so p is greater than alpha, so again, we do not reject the null hypothesis. Testing claims about the standard deviation or variance. The requirements are the same as we had for the requirements for the confidence interval. Simple random sample, and the population must be normally distributed. The properties, the distribution is skewed right, it is not symmetric. All values are greater than 0. And as degrees of freedom increases, the chi-square distribution starts approaching the normal distribution. Using Minitab, okay, again, you won't get any questions asking you to actually do the entire test because the student version of Minitab does not do a one sample variance or standard deviation test. But know that it's very similar to the hypothesis test you did with proportion and the two that you did with mean. All right, so now you understand hypothesis tests. There's some problems that you can look at that I'll have assigned for you to try out of your textbook. You have some Minitab labs that'll give you more practice using Minitab, and that's the end of Chapter 7.